Hello, this is our project, A Statistical Symphony, Data Analysis of Classical Compositions. I'm
I'm
Atlas.
Claudia. So we decided to pick the topic that we did because of a combined interest in music and Spotify, as well as history, which is why we decided to look at archival musical data, classical compositions. And our main purpose was to find out what factors determine the popularity of a song and what characteristics make a classical composer successful. We hypothesized that a major factor would be the length of a song. So as time goes on, shorter songs are more popular, and we hypothesized that a musical genre would have something to do with it and it would correlate with popularity.
So the first step was data collection. Our data set that we found was through a study done at the University of Michigan, funded by the National Endowment for the Arts. Some inconsistencies that we wanted to fill in required using the Spotify API and then using a Wikipedia page that had composers' birth and death years as an HTML.
And for the data cleaning process, it mainly consisted of selecting what data we wanted, carrying out some mapping and mean calculations, and then filling in missing lengths and names with Spotify API, and then filling in missing birth and death years with the Wikipedia.
So kind of the cleaning for this, the first part was just up here, we're dropping all the columns that we don't want, and then we're mapping in the country maps and the orchestra locations, which were given in the code book for the data set. The secondary thing we did was finding the song length. If min and max were available, we used that. If they weren't, we used the title to call to the Spotify API using the setup and put that in. And then finally, last thing that we need to fill in our inconsistencies was finding birth and death years of composers. To do this, we first normalized all the names because there was a lot of accents and all that didn't exactly match between the Wikipedia and our data set. After that, we went through the Wikipedia to create an entire dictionary of the composers and their birth and death years, and then we went through anything missing in the CSV, and if they were found in the dictionary, their birth and death years were put in.
So overall, this project has a lot of interesting insights. We're going to focus on the main two that answer our hypothesis.
So the first one that really answers our hypothesis is, does song length and time have any correlation? And using a linear regression on scikit-learn, we learned that there is no regression at all, but this did require eliminating outliers, but we'll speak on that later.
And the insight four was the era. So we categorized by the birth year of the composer into 7 different musical genres. And this is where we had to use our new knowledge. We found a new function called dot transform, which is the same as dot apply, but make sure that the original function and the new function have the same size because we had errors previously. And this let us calculate by using group bys and size and sums, as well as a percentage formula, what era was the most popular. It turned out to be Romantic era, with 93% of orchestras primarily performing it. So our hypothesis was correct, and genre does have an impact on popularity.
So our first visualization was lowest trend lines, which just are trend lines that actually kind of follow the data. We showed two things versus one, age versus output, which had a peak at 52 years old, and then age versus popularity, which was like the number of performances for any artist that at that age. In the peak, there was only 42 years old. And then here's our coding.
Visualization 2 was a chloropleth, so we wanted to see kind of where each composer was from. We had to do some adjusting because Germany was oversaturated, which was we used log values and show distribution.
And then the last one, this is a new visualization we learned, is parallel categories, and it shows every single possible like combination that appears between whatever categories put in. In this case, we generalized the nations into regions, the lengths into 10-minute increments, and then the orchestra regions into regions of the US. And what we saw was that there.
So we briefly mentioned an insight earlier on the slides that took a diversity index using the eras, length of songs, as well as composer nationalities. to find out what region of the US was the most diverse. So we took this and made it into GUI, so to allow the user to pick how much each factor weighed, and that outputted a new table with newly computed diversity indexes.
And then facing complexity, when we were data cleaning, we first had to learn how to use the Spotify API, which used parameterization in order to pass in multiple different like features and like access codes and all. And then another thing is that when we were trying to normalize the names between the Wikipedia, we had to use the Unicode module, which is a new module we learned. Basically, what it does is it takes any like asterisks or like any form of accents and it moves it out like after the letter, and then from there we could remove them all.
Yeah, so some other things that we learned was a lot of mathematics behind insights. So we used, for example, the standard deviation form in Pandas, which is something that I'd never seen before, and we use that for diversity index, for skewing and things that made it a bit difficult to kind of make an insight out of our data, is where we used the lower bound and the upper bound from statistics to kind of eliminate the outliers. We also used the Z-score or normalization standardization formula as well for the diversity index, because we wanted to kind of get all the values to be one thing that the user could interpret.
And then some new knowledge is we learned about the transform pandas function, which instead of apply, which gives you one group with a value, it would apply that value to every single thing that like kind of matches that group, so it's the same size and doesn't cause errors. And then, as we explained, the parallel plotly graph is also something new that we learned.
Some other few additional things we learned was, for example, index max and index minimum. So for a lot of the insights, because we ended up computing a new subtable, for example, like for the orchestra popularity, like we used the sum of total orchestra performances. So for those, the orchestra location became the new index. So for that, we used normal max and min and also the index max and min for the corresponding location.
Yes. And one last thing we also learned is how to use the merge function, which is sort of similar to transform, but for a slightly different purpose. And what it does is it basically does the same thing where it matches on a feature and then it appends a column value for each and every one. So if you have everything in a group, it will apply that to the group.
So overall, while we faced some struggles in this project, specifically during the initial cleaning and transferring of files, we also learned a lot of new knowledge and a lot of new modules and new ways to code that we can hopefully apply in the future. Even though we did rely heavily on a lot of what we did in lectures and homework, it was a great opportunity to learn even more about especially pandas and visualizations.
Thank you.